This video is another in the series from Math 1224 for UTSA. Today, we're going to talk about power series representations a little bit more. I want to present two examples, at least two, probably just two. So here's the standard geometric power series representation for 1 over 1 minus x, right? Power series. And centered at 0. And I want to talk about two things. First of all, this is centered at 0 with a radius of 1. That's the power series representation. We'll look at an interactive Desmos graph of the power series representation in a few minutes. There are two things to talk about. One we've talked about extensively. The other, not as much. You're kind of expected to synthesize this with some other stuff you've seen before. So what if I wanted to move the center not to be at 0, but to be at -1? So instead, I would have something like -3 to 1 is the interval of convergence for the power series representation. The center is at -1. How would I do that? How do I move the center, right? So what I can do is look at this guy and say, well, is there a way I can rewrite this so that I have in place of x, I have something where plugging in -1 creates a 0 in that position, okay? Well, one way to do that is to say, rewrite this in the following way. I can add 1 to the first term, and then in parentheses, since I'm subtracting, if I add 1 here, I'm really subtracting 1. So this is the same thing. 2 minus x plus 1 is the same as 1 minus x. I've added 1 here, and I've added 1 here. And since I'm subtracting, that's equivalent to doing nothing at all, right? Now I can factor out a 2 out of the denominator. Write this as 1/2 times 1 over 1 minus, and there's a couple ways to write this. I guess I'll write this as x plus 1 over 2. Oops, x plus 1 over 2. Or if you want, you could write this as x over 2 plus 1/2, whatever you want, right? So this is the same function, but I've rewritten it in such a way that plugging in -1 creates a 0 there. As well, I still have the structure of 1 over 1 minus something. So that's still a geometric series. So I can rewrite this as, this is equal to 1/2 times the series as n goes from 0 to infinity of x plus 1 over 2 to the n power. This is a power series representation for the same function with a different center. Let's check that out. This expression has to be between -1 and +1 to have convergence for the power series. So if I say, okay, -1 is less than x plus 1 over 2 is less than 1, double everything. So -2 is less than x plus 1 is less than 2, and then subtract 1. I'll have -3 less than x less than 1. So that interval convergence for that power series is now -3 to 1. So the center has moved to -1, but it's the same function. Okay, so let's go look at the Desmos version of this. So you can see I have the graph of 1 minus 1 over x there, and I have the power series representation here. And if I increase n, you can see that green curve matches the function really well on the interval -1 to 1, right? So now if I change the power series I'm using, I put the 1/2 out in front, and I change this inside part here. Right? And I change the interval to be -3 to 1. You can see now we have this green line, and as I increase n, that curve matches the function really well. So I have moved the center to be from 0 to be at -1 instead, okay? And that's just by modifying the function a little bit. Okay. So another example, because this is something we've already done extensively. What if instead, let's scroll down to a new copy of this. What if I don't want to move the center somewhere on this chunk of the graph? What if I want the center to be over here? Like, what if I wanted the center to be at 2 on the other side of the asymptote? Okay, how would I do that? Well, the first thing I'm going to do is I'm going to draw on here the vertical asymptote so we can refer to it more easily. I'm going to do this in 2 stages. The first thing I'm going to do is take this section. This is where the power series representation, that's the interval, right? I want to swap it across the line of symmetry there. It's not, well, this is not symmetrical across a vertical line, but I'm going to do a swap, and you'll see why. Maybe it's clear already what's going to happen. I'm going to swap across a vertical line first, and we'll swap across a horizontal line second, and then we'll get this section copied down to here, essentially. Okay, so I want to have the following. When I plug in x equals 2, I want, when I plug in x equals 2, because ultimately I want to be down here. When I plug in x equals 2, I want the power series to think we're over here. So I'm ultimately going to be swapping this point over to this point, okay? And when I put in say 2.5, then I want the graph to think we're here, or the power series to think we're here, so I want to swap across this line to right there. Okay. And then when I put in, say, 1.5, I want the power series to think we're dealing with this point, so I want to swap across to here. So what I'm doing is, I want to switch across that asymptote to represent this function instead. How am I going to do that? The graph could be done better, but whatever, close enough. Well, I want to take the point 0 and have it result in or rather, I want to take the x-coordinate 2. When I plug it in, I want to get 0 as a result. Okay, so I want 2 to become 0. When I plug in 2.5, I want to get negative 0.5. So 2.5 should become negative 0.5. When I plug in 1.5 to get this point, I want to instead get this point, which is 0.5. So 1.5 as an input to this formula we're going to develop should give me 0.5. And pretty quickly you'll notice that 2 minus x, or in other words, u equals 2 minus x, this is the substitution formula that will do that. So if I take this guy and I go, okay, I'm going to instead use y equals 1 over 1 minus 2 minus x. I'll make that substitution. This power series representation will give me this guy, where is it? This guy over here instead. I'm swapping across that line of symmetry by making that change. Okay? Now, what I really want is to be down here. So I need to swap across the x-axis. So when I plug in 2, I want to receive this point instead of this point. Now you might notice, oh, well, the y-coordinate here is -1 and the y-coordinate here is +1. Okay, basically I need to negate the y-coordinate to get down there. So I'm going to instead do y equals negative times, negative of 1 over 1 minus 2 minus x. This is the function that I want to use for the power series representation. It's still the same function ultimately, because I've reflected around, I'm now getting these coordinates, but I'm going to use this formula. Okay, so that means I'm going to have to use this power series representation. This equals the negative of the sum is n goes from 0 to infinity of 2 minus x to the n power. Okay, and this will be convergent whenever 2 minus x is between -1 and +1. So if I subtract 2 on all sides, or all components, I'll get -3 is less than -x is less than -1, right? Because I subtracted 2, and then negate everything, I'll get 3 is greater than x is greater than 1. So x is between 1 and 3, okay? So that, as I pointed out, that's this section right here, okay? So let's go get a visual of that. Okay, so if I go over here, and let me get rid of some of this. We don't need that. It's from the previous one. That was just x. So I'm going to change this to be the negative in front of the power series, and then 2 minus x. And I'm going to change the interval to be from 1 to 3. Okay, so now you can see I've got this line segment on the graph, and if I increase n, now I'm getting a power series representation for that section. It's the same function the whole time, but because I reflected across the axis of symmetry, or I use the symmetries of the graph itself, the symmetry, my symmetry being x equals 1, because I used that, I flipped over to the other side. Okay, so now that we've done this the hard way, I want to look at, is there I don't want to say easier, but different way to get this that you might find to be easier? And the key element is in the second swap, we had to swap across the x axis, so we had to have this negation here. So let's keep that in mind, and let's try something a little bit different. What if I started with y equals 1 over 1 minus x, and I knew that I wanted to swap across the axis of symmetry? I could go ahead and negate the top and bottom like this, and then I've got that minus sign in the numerator that I'm going to need for the second swap. Now I can focus on manipulating the denominator and leave that minus sign in the top the whole time. So what I could do is I could say, well, this is the same as, and this takes a little bit of creativity. You just got to think, okay, what are my options? If I were to say, add 1 here, and then subtract 1 here, right? That's really the same thing. Then I can group the x and the 2 together in parentheses, and I can factor a minus sign out of that grouping. So this is 1 minus 2 minus x. So we did all the same work as the geometric interpretation, but it wasn't clear that we would need this from the get-go. But now you can see, oh, this is one thing I can try. Negate the top, negate the bottom, and then work on the bottom. And that will be a way to deal with getting centers that are across an asymptote.